from sonar scans revealing geometric formations beneath the waves to vanished ships, underwater cities, and unexplained regions like the Bermuda Triangle, the Atlantic has become more than an ocean of currents and depth. Stories of lost civilizations, sunken continents, and mysterious discoveries have only deepened the mystery. In this documentary, we explore what has been found in this ocean, the stories passed down through history, and how they may connect to what lies below the surface. We'll examine the myths, the discoveries, and what makes it Earth's most mysterious ocean. You'll hear the legends, see the evidence, and decide for yourself what the Atlantic Ocean is truly hiding. Many of the legends surrounding the Atlantic Ocean can be traced back to one specific region, known as the Bermuda Triangle. This area has been linked to stories of ships and aircraft that disappeared without a clear trace. Over time, these accounts have shaped the idea that something unusual may be happening in this part of the ocean. Reports often describe ships found abandoned and aircraft that suddenly lost contact. In some cases, instruments stopped working without warning. The Bermuda Triangle is usually defined by 3 points: the coast of Florida, the island of Bermuda, and Puerto Rico. It is a large and heavily traveled area used by commercial ships and aircraft every day. Despite this, several well-known incidents have continued to draw attention. One of the earliest stories connected to this region involves a ship known as the Ellen Austin. In the late 19th century, it was reported that the vessel came across an abandoned ship drifting in the open ocean. The ship showed no visible damage. Its cargo was still in place, and there were no signs of a struggle. After observing it from a distance, the captain decided to send a small group of his crew aboard to take control of the vessel and guide it back to port. For a short time, the two ships traveled together. Then a storm moved through the area and separated them. When the Ellen Austin later located the drifting ship again, it appeared exactly as before. It was still intact, still moving with the current, but the second crew had also vanished. No explanation was found, and the ship was eventually left behind. Over time, different versions of this story appeared, and some details changed. Even so, it became one of the earliest accounts often linked to the region. Several decades later, a far more serious disappearance took place. In March 1918, the USS Cyclops, a large US Navy cargo ship, departed from Barbados with more than 300 people on board. It was carrying a heavy load of manganese ore and was expected to arrive in Baltimore within days. The journey appeared routine. The ship sent no distress signal, and its last known message indicated that conditions were normal. After that, it was never heard from again. The ship did not reach its destination, and no wreckage was ever found. A search operation covered a wide area of ocean, but there was no sign of debris, lifeboats, or survivors. The size of the vessel and the number of people on board made the disappearance especially notable. To this day, it remains one of the largest unexplained losses in US naval history. But in December 1945, another incident occurred, this time involving aircraft. A group of 5 US Navy training planes, known as Flight 19, took off from Florida for a routine exercise. The mission followed a standard route that had been completed many times before. Shortly after reaching their first checkpoint, the lead pilot reported that his compass was no longer working correctly. He also expressed uncertainty about their location. Radio communication continued for some time, and it became clear that the pilots were confused about where they were. At one point, they believed they were flying over land, but their descriptions did not match their actual position. As time passed, their transmissions grew weaker. The weather began to change, and visibility became worse. Eventually, contact was lost completely. A search and rescue mission was launched soon after. One of the aircraft sent to locate the missing planes also disappeared shortly after takeoff. Despite a large search effort, no confirmed wreckage from either the training flight or the rescue plane was ever found. More than 20 years later, another case drew attention, this time much closer to land. In December 1967, a small boat called the Witchcraft left the Miami shoreline for a short evening trip. The owner and a passenger planned to remain near the coast while observing the city lights. Shortly after departure, the owner contacted the Coast Guard. He reported that the boat had struck something in the water and needed assistance. The situation did not appear urgent, and he stated that he would signal his position. Rescue crews arrived at the reported location in less than 20 minutes. When they reached the area, the boat was no longer there. There was no debris in the water, no oil slick, and no sign of the passengers. A larger search operation followed, covering a wide section of ocean near the coast, but nothing was found. Fast forward to December 1948. A Douglas DC-3 plane departed from Puerto Rico, heading toward Miami with more than 30 people on board. Before takeoff, minor technical issues had been reported, including problems with the aircraft's electrical system. Despite this, the flight proceeded as planned. During the journey, communication with ground control became less reliable. The aircraft continued to send updates, but signals were weaker than expected. In its final known transmission, the plane reported its position not far from Miami. After that message, contact was lost, and the aircraft never arrived at its destination. These cases, separated by decades, share several similarities. Ships and aircraft disappear without leaving clear evidence behind. In some situations, communication ends suddenly. In others, crews report problems with navigation or instruments shortly before contact is lost. Over the years, researchers and investigators have examined these incidents in detail. Most explanations point to natural and technical causes. Strong storms, sudden weather changes, and powerful ocean currents can affect both ships and aircraft in this region. Navigation errors can occur when visibility is low or when instruments fail. In some cases, mechanical issues or human decisions may have played a role. These factors are widely accepted as the most likely explanations for many of the disappearances. At the same time, the lack of physical evidence in certain cases has left some questions unanswered. Because of this, alternative ideas have also been discussed. Some theories suggest that unusual environmental conditions may affect navigation or communication systems in this part of the ocean. At the same time, some people have offered a very different idea. Instead of focusing on weather or navigation, they believe the answer may lie in a living creature. In these interpretations, the disappearances are sometimes linked to a being long known in maritime history as the Kraken. The Kraken is usually described as a massive sea creature with long, powerful tentacles. According to old accounts, it lived deep beneath the ocean and only appeared near the surface on rare occasions. When it did, sailors reported seeing large shapes in the water, followed by movement strong enough to disturb the sea around them. The legend of the Kraken comes from northern European waters, especially from Scandinavian traditions. However, over time, similar reports began to appear across the Atlantic Ocean. Sailors from different countries described encounters that shared the same details. They spoke of something large beneath their ships, something that could not be clearly seen, but was powerful enough to affect the water and anything on it. In fact, some researchers have pointed out that we have more detailed images of the surface of Mars than we do of the deep ocean floor on Earth. This lack of knowledge leaves room for many questions. Because of this, some people believe it is not impossible that very large and unknown creatures could exist in the depths of the Atlantic. The ocean reaches extreme depths where sunlight does not reach, and conditions are very different from those at the surface. In such an environment, it is difficult to observe or study marine life directly. This has led to the idea that something large could live far below, rarely coming into contact with the surface, but still capable of affecting ships or aircraft under certain conditions. In recent years, there have been reports that have brought this idea back into discussion. In one widely shared account, footage captured in the South Atlantic appeared to show a large squid-like creature moving in deep water. While the exact details of the sighting remain unclear, it renewed interest in the possibility of unknown or rarely seen marine animals. Despite these claims, most scientists approach the idea of the Kraken with caution. They do not dismiss the historical reports, but they interpret them differently. Many researchers believe that sightings of the Kraken were likely encounters with large squid, particularly the giant squid or the colossal squid. These animals are real and can reach impressive sizes, with long tentacles and strong bodies adapted to life in deep water. The discovery of these species changed how many experts view older accounts. What was once considered impossible is now known to exist. However, even the largest known squid do not match the most extreme descriptions found in historical reports. This has led to the idea that some sightings may have been exaggerated, or that unusual conditions at sea made these animals appear larger than they actually were. Another explanation comes from a concept known as deep-sea gigantism. This refers to the tendency of some deep-sea animals to grow much larger than their relatives in shallower waters. Scientists believe this happens because of the unique conditions in the deep ocean, including low temperatures, high pressure, and limited food sources. In this environment, a larger size can be an advantage for survival. At the same time, studying these depths remains extremely difficult. The pressure in the deepest parts of the ocean is many times greater than at the surface, strong enough to damage most equipment. Light does not reach these areas, and visibility is very limited. Even modern technology can only explore small sections for short periods of time. Because of this, scientists acknowledge that there may still be species that have not yet been observed. And yet the Kraken is only one of many mysteries connected to the Atlantic Ocean. One of the most discussed discoveries lies just off the coast of the Bahamas, near the island of North Bimini. In 1968, a group of divers exploring shallow waters made an unusual observation. About 5 to 6 meters below the surface, they found a long line of large stone blocks arranged in a clear, almost organized pattern. The formation stretches for roughly 800 meters and appears to follow a straight path before curving slightly at one end. At first glance, the stones resemble a paved road or the remains of a wall. Many of the blocks are flat and rectangular, some measuring several meters across. They lie side by side, forming a continuous surface that looks very different from the surrounding seabed. Because of this, the site quickly became known as the Bimini Road or Bimini Wall. Could this be the remains of something built long ago? Some researchers and independent investigators believe it might be. They argue that the alignment of the stones, along with their size and shape, suggests deliberate placement. Over time, this idea became closely linked to the legend of Atlantis, a lost civilization said to have disappeared beneath the ocean. The timing of the discovery also drew attention, as it occurred close to a prediction made decades earlier that remnants of Atlantis would be found near Bimini. However, most geologists offer a different explanation. According to scientific studies, the formation is made of a natural material called beach rock. This type of rock forms when sand, shells, and other sediments are cemented together over time in shallow coastal areas. As sea levels change and erosion takes place, the rock can break into large, flat slabs. These slabs can settle into patterns that appear structured, especially when viewed from above. Detailed examinations of the site have shown that the blocks are not perfectly uniform and do not sit on top of one another in a way expected from human construction. Instead, they rest directly on natural bedrock or loose sand. While the formation may look artificial at first, the current scientific consensus is that it formed through natural geological processes. Even so, its appearance continues to raise questions. The clean lines, the scale, and its location beneath the water make it one of the most visually striking formations in the Atlantic. Further out in the Atlantic, another discovery has sparked similar debates. In 2013, an amateur sailor named Diocleciano Silva reported detecting a large pyramid-shaped structure on his sonar equipment. The object was located between the Azores islands of São Miguel and Terceira, in an area known for deep waters and volcanic activity. According to the initial report, the structure appeared to have a square base and sharply defined sides. It was estimated to rise about 60 meters from the ocean floor, with a wide base covering several thousand square meters. What made the finding especially intriguing was the claim that it seemed aligned with the cardinal directions, a feature often associated with ancient human-built structures. Could such precision occur naturally? The claim quickly gained attention online, with many linking it once again to Atlantis or other lost civilizations. However, the evidence remained limited. The original sonar images were low in resolution, and no detailed scans or direct visual confirmation were made public. This made it difficult for scientists to evaluate the structure with certainty. Experts from the Portuguese Navy and the University of the Azores have expressed skepticism about the interpretation. They suggest that what appeared to be a pyramid is more likely a natural underwater formation, such as a volcanic peak. The Azores sit along the mid-Atlantic ridge, a region shaped by tectonic activity where underwater mountains are common. In such environments, volcanic formations can take on steep, angular shapes. When viewed through sonar, especially lower quality equipment, these features can appear more regular and geometric than they actually are. This effect can create the illusion of straight edges and flat surfaces. Without further exploration using advanced equipment, the true nature of the structure remains uncertain. For now, it stands as an example of how limited data can lead to very different interpretations. Another case comes from deeper waters near the coast of Cuba. In 2001, a research team using sonar technology detected unusual shapes on the ocean floor at depths between 600 and 750 meters. The images showed large formations that appeared geometric, including shapes resembling pyramids, circles, and straight lines spread across a wide area. Unlike the Bimini Road, these structures lie far beyond the reach of sunlight in complete darkness. At such depths, direct exploration is extremely difficult. The pressure is immense, and visibility is limited, making it challenging to confirm what sonar images suggest. Some researchers involved in the discovery suggested that the formations could be the remains of an ancient settlement. They pointed to the apparent organization of the shapes, which seemed to form patterns similar to streets or buildings. This interpretation led to speculation about a lost civilization that may have existed thousands of years ago before being submerged. However, other experts urge caution. Sonar images can sometimes be misleading, especially when interpreting complex natural terrain. The ocean floor is not flat. It is shaped by volcanic activity, sediment movement, and tectonic shifts. These processes can create formations that appear structured when viewed from a distance or through indirect imaging. Follow-up missions using remotely operated vehicles captured limited footage of the site. While large stone-like shapes were visible, the images were not clear enough to confirm whether they were natural or artificial. As a result, the site remains controversial. At present, there is no widely accepted scientific evidence that these structures are man-made. Still, the depth, scale, and unusual patterns continue to make this one of the more debated discoveries in the Atlantic. Another unusual formation has been observed much closer to the United States coastline, in an area known as the Blake Plateau. This region lies in the western Atlantic, off the coasts of Florida, Georgia, and the Carolinas. It is a broad underwater plateau, located at depths of several hundred meters, where the seafloor begins to slope down into the deeper ocean. During sonar mapping of this area, researchers noticed something unexpected. The images revealed long, straight lines crossing the ocean floor in different directions. In some places, these lines intersect, forming shapes that resemble a grid or a network. When viewed from above, the pattern can look surprisingly organized, almost like a map of streets or city blocks. At first glance, the regularity of these lines raised questions. Some observers described the formations as too perfect to be random. The straight edges and repeating layout seemed unusual for a landscape shaped only by natural forces. Because of this, a few interpretations suggested that the patterns might be the remains of some kind of large-scale structure, possibly hidden beneath layers of sediment on the ocean floor. However, scientists who study the region offer a different explanation. The Blake Plateau is influenced by powerful ocean currents, including parts of the Gulf Stream system. These currents can shape the seafloor over long periods of time by moving sand, sediments, and small particles across the surface. As these materials shift, they can settle into long, narrow ridges or grooves. In addition to currents, the underlying geology also plays an important role. The ocean floor in this region contains natural fractures and faults formed by tectonic activity over millions of years. These cracks can guide how sediments accumulate, creating straight or angled lines that follow the structure of the rock beneath. When these geological features combine with the movement of water, they can produce patterns that appear far more regular than expected. Another factor to consider is how sonar imaging works. Sonar does not capture a direct photograph. Instead, it builds an image based on sound waves reflecting off the seafloor. This process can sometimes exaggerate shapes or highlight certain lines, making natural features look more defined and geometric than they are in reality. Across other parts of the Atlantic, including areas near Madeira and the Azores, scientists have identified large underwater terraces and step-like formations. These features often appear as flat platforms or layered stairs descending along underwater mountains. In some cases, they look surprisingly regular, almost like constructed levels carved into the rock. These formations are usually found on seamounts, which are underwater volcanic mountains. Over time, lava flows, erosion, and changing sea levels shape these structures. As waves and currents wear down the rock, they can create flat surfaces at different heights. When seen from above or through sonar, these layers can resemble steps or terraces. The Atlantic Ocean has always been central to the search for Atlantis, largely because of its connection to ancient texts. Plato described Atlantis as a powerful civilization that existed beyond the known world and was eventually lost beneath the sea. Over time, many have tried to match his description with real locations. Regions like the Azores and the area near Gibraltar have been suggested as possible sites. Some theories propose that parts of these regions were once above sea level and later submerged due to rising oceans or geological events. The presence of underwater terraces and unusual formations adds to this idea, even if the connection remains unproven. Scientists, however, explain these features through natural processes. Changes in sea level over millions of years, combined with volcanic activity and erosion, can produce the layered landscapes seen today. These formations are not unique to the Atlantic and can be found in other parts of the world as well. Even so, the possibility of lost landscapes beneath the ocean is not entirely dismissed. Sea levels have changed significantly throughout Earth's history. Entire coastlines have shifted, and some ancient settlements are now underwater. If parts of the Atlantic really have disappeared beneath the sea, could something else have once existed there as well? For centuries, sailors and map makers believed exactly that. They spoke of an island that did not stay in one place, an island that appeared and disappeared without warning. This place was known as High Brazil. High Brazil was not just a story told among sailors. It appeared on real maps for hundreds of years. The earliest known reference dates back to 1325, when it was marked on a nautical chart as a small island west of Ireland. Over time, it continued to appear on maps created by different cartographers across Europe. In many cases, it was drawn as a near-perfect circle, sometimes with a line running through its center, as if a river or channel divided it in two. Why would so many map makers include the same island if it had never been confirmed? The origin of its name comes from Celtic mythology. It is linked to a figure known as Braesal, often described as a powerful or high king in Irish legend. In these early stories, High Brazil was not just land. It was a place connected to the other world, a distant and almost unreachable realm. Some described it as a land of knowledge, others as a place of peace. In many versions, it was said to be hidden most of the time, covered by a thick mist. According to tradition, the island could only be seen once every 7 years. On that day, it would appear clearly on the horizon before fading again into the fog. This detail became one of the most consistent parts of the legend. There are several accounts from individuals who claim to have seen or even reached the island. One of the most well-known stories comes from the 17th century. In 1674, a Scottish captain named John Nisbet reported that he had landed on High Brazil. According to his account, members of his crew went ashore and explored the island. They described unusual details, including large black rabbits and a figure living in a castle, often referred to as a magician. The story may sound strange, but it was recorded as a serious claim at the time. Centuries later, sightings continued. In the 19th century, Irish writer T.J. Westrop claimed that he had seen the island on multiple occasions. In one instance, he even brought others with him to confirm it. They reported seeing a dark landmass rising from the sea, with hills and shapes that seemed too clear to be imagined. Despite these reports, repeated expeditions failed to locate the island. Ships were sent from places like Bristol as early as the 15th century, searching for High Brazil based on its mapped location. None of these journeys succeeded. Over time, confidence in its existence began to fade. By the late 1800s, the island was removed from official maps. So what explains this long history of sightings and belief? One possibility is that High Brazil began as a simple cartographic error. Early map makers often relied on second-hand reports, and mistakes could easily be copied from one chart to another. In some cases, map makers even included false features as a way to protect their work from being copied. If another map repeated the same error, it could reveal plagiarism. Another explanation focuses on natural optical effects. In certain weather conditions, light can bend as it passes through layers of air with different temperatures. This can create what is known as a superior mirage, where distant land appears lifted above the horizon or distorted into unusual shapes. These mirages can be detailed enough to resemble real landscapes. Even today, similar phenomena are observed at sea. In some cases, ships appear to float above the water, or coastlines seem closer than they really are. For sailors in earlier centuries, without modern instruments, such sights could easily be mistaken for new land. Still, the story of High Brazil remains difficult to fully explain. It persisted for over 500 years, appearing on maps and in written accounts across different countries and time periods. Unlike many myths, it was treated as a real location, something that could be found, not just imagined. Even though the Atlantic Ocean is often connected to legends and lost worlds, not all of its stories belong to myth. In some cases, entire cities have truly disappeared beneath the water. One of the clearest examples is Port Royal, a place whose rise and sudden destruction were recorded in detail. Port Royal was located on the coast of Jamaica, at the entrance to a natural harbour. Founded in the late 15th century, it grew rapidly and by the 17th century became one of the most important ports in the Caribbean. Its position along major trade routes made it a centre of commerce, shipping and naval activity. Ships from across the Atlantic passed through its harbour, bringing goods, wealth, and people from different parts of the world. At the same time, Port Royal developed a very different reputation. It became closely linked to privateers and pirates who operated in the region. These crews used the city as a base, launching attacks on passing ships and coastal settlements. As a result, large amounts of wealth flowed into the port. Taverns, markets, and trading houses expanded quickly, and the city became known for its busy and crowded streets. By the late 1600s, Port Royal was one of the wealthiest places in the Atlantic world. Thousands of people lived there, and hundreds of buildings were packed into a relatively small area of land. However, the ground beneath the city was unstable. Much of it consisted of loose, water-saturated sand. Buildings were often constructed close together, and over time they became heavier as stone materials replaced earlier wooden structures. On June 7th, 1692, everything changed. A powerful earthquake struck the region without warning. Within minutes, large parts of the city began to collapse. The ground beneath Port Royal underwent a process known as liquefaction. The sand lost its strength and behaved almost like a liquid. Buildings tilted, cracked, and sank into the earth. Entire sections of the city slid into the sea. Streets that had once been crowded disappeared beneath the water. Eyewitnesses described people being pulled down along with collapsing structures, while others tried to escape toward higher ground. Shortly after the earthquake, a tsunami followed, sending waves through the harbor and adding to the destruction. The disaster caused a massive loss of life. A large portion of the population was killed either during the earthquake or in the days that followed. Survivors faced further danger from disease, lack of clean water, and the destruction of homes and supplies. Fires and storms in the years after the event prevented any full recovery. Attempts were made to rebuild Port Royal, but the city never returned to its former state. Over time, its role as a major port was taken over by nearby Kingston, which became the new center of trade and government. What remained of Port Royal gradually declined, leaving behind only a small settlement. Today, parts of the original city still lie underwater. Archaeological studies have revealed streets, buildings, and everyday objects preserved beneath the sea. Because the conditions limit oxygen, many materials have survived in remarkable detail. These findings provide a rare and direct look at life in a 17th century port city. Port Royal is often described as one of the best preserved underwater archaeological sites in the world. It is sometimes referred to as the city that sank, not as a legend, but as a documented historical event. Its story shows how quickly a place can disappear when natural forces act without warning. The Atlantic Ocean does not end at its visible shores. Through narrow passages such as the Strait of Gibraltar, its waters flow into the Mediterranean Sea, creating a connected system that has shaped human history for thousands of years. This smaller sea, often seen as separate, is in many ways an extension of the Atlantic world. Along its coasts, some of the earliest civilizations developed, traded, and expanded, and in certain places entire cities were later lost beneath its waters. One of the most remarkable examples is Herakleion, an ancient Egyptian port city that once stood at the mouth of the Nile. Known to the Egyptians as Thonis and to the Greeks as Herakleion, it was a major center of trade and religion for centuries. Ships arriving from the Mediterranean were required to pass through this port, making it one of the most important entry points into Egypt. Herakleion was not built on solid ground in the traditional sense. The city stood on a network of small islands in the Nile Delta, connected by canals, bridges, and waterways. Large temples, including a central sanctuary dedicated to the god Amun, formed the heart of the city. Around them, docks, markets, and residential areas spread across the landscape. Goods from across the Mediterranean passed through its harbors, and merchants from different cultures lived and worked within its walls. Over time, however, the same conditions that made the city possible also made it vulnerable. The land beneath Herakleion consisted of soft clay and sand, saturated with water from the surrounding delta. Gradual changes in sea level, combined with natural forces such as earthquakes and floods, began to weaken its foundation. Historical records suggest that the region experienced both seismic activity and powerful storms. These events likely triggered a process similar to what occurred in Port Royal centuries later. The ground lost its stability, and entire sections of the city began to sink. Buildings collapsed, canals shifted, and the water slowly claimed the land. By around the 8th century AD, Herakleion had fully disappeared beneath the sea. For more than 1,000 years it remained hidden. Its location became uncertain, known only through scattered references in ancient texts written by historians such as Herodotus and Strabo. Many believed the city had existed, but no physical evidence had been found. That changed in the year 2000. when underwater archaeologist Frank Goddio and his team located the remains of the city in Abu Qir Bay, off the coast of Egypt. Using modern technology, including sonar mapping and underwater scanning, they identified structures buried beneath layers of sand and sediment. The discoveries were extensive. Archaeologists uncovered large statues, temple remains, coins, and everyday objects that had been preserved underwater. More than 70 shipwrecks were found in the area, making it one of the richest underwater archaeological sites ever discovered. The layout of the city, with its canals and interconnected islands, became visible once again. Despite these findings, much of Heracleion remains unexplored. Only a small portion of the site has been studied in detail, and large sections are still buried beneath sediment. The city offers a rare example of how an important center of civilization can disappear almost entirely, leaving only traces beneath the sea. Another example of a submerged city, even older in origin, lies along the coast of southern Greece. Known as Pavlopetri, this site dates back more than 5,000 years, making it one of the oldest known underwater cities in the world. Pavlopetri was built during the Bronze Age and was once a thriving coastal settlement. Unlike Heracleion, which was rediscovered through large-scale exploration, Pavlopetri is located in shallow water, just a few meters below the surface. Its remains are visible to divers and researchers, offering a clear view of an ancient town layout. The city was first noted in the early 20th century and later studied in greater detail during the 1960s. Since then, modern surveys have mapped much of the site. Streets, building foundations, courtyards, and burial areas have all been identified. The level of preservation is unusually high, allowing researchers to reconstruct how the settlement was organized. The layout suggests a structured community with defined spaces for living, trade, and daily activity. This indicates that even in prehistoric times, people were building organized towns with planning and purpose. The presence of graves and storage areas also provides insight into the social and economic life of its inhabitants. The submersion of Pavlopetri did not happen suddenly. Instead, it appears to have been caused by a combination of slow geological changes. Tectonic movement, which shifts the Earth's crust, likely caused the land to sink gradually. At the same time, rising sea levels contributed to the process, eventually placing the entire city underwater. In the northern part of the Atlantic, in the area we today call the North Sea, there was once a vast stretch of land where water now lies. This place is known as Doggerland. Today, it is completely hidden beneath the sea, but thousands of years ago, it was a living, breathing landscape filled with rivers, forests, animals, and people. Doggerland was not a small island or a narrow land bridge. It was a massive region that connected what is now Great Britain to mainland Europe, including parts of the Netherlands, Germany, and Denmark. Instead of open water, There were wide plains, marshes, lakes, and dense woodlands. Large rivers flowed through the land, including one huge river system formed by the merging of rivers, like the Thames and the Rhine. This created a rich and fertile environment, perfect for life. For thousands of years, people lived there. These were Mesolithic hunter-gatherers moving across the land, fishing in rivers, hunting animals, and building simple communities. Evidence of this has been found in tools, bones, and even human remains that have been pulled from the seabed by fishermen. Mammoth bones, ancient weapons, and carved tools all point to a land that was once full of activity. So how did such a large, inhabited world disappear completely? The answer begins with the end of the last ice age. During the ice age, huge parts of the Earth were covered in thick layers of ice. Because so much water was locked inside glaciers, global sea levels were much lower than they are today, sometimes by more than 100 meters. This exposed large areas of land, including Doggerland. What is now the bottom of the North Sea was once dry ground. But as the climate slowly warmed, the ice began to melt. This melting did not happen all at once, but over thousands of years. As glaciers retreated, they released enormous amounts of water back into the oceans. Sea levels began to rise steadily. At first, this would have been a slow and gradual change, but Doggerland started to shrink. What had once been a continuous landmass slowly turned into a series of wetlands and islands. Rivers expanded, marshes spread, and the sea pushed further inland. People living there would have had to adapt, moving their settlements again and again as the land changed around them. Then came what may have been the final blow. Around 8,000 years ago, a massive underwater landslide occurred off the coast of Norway. This event, known as the Storegga Slide, triggered a powerful tsunami that swept across the North Sea. Waves would have crashed into the remaining parts of Doggerland, flooding already fragile land. For the people living there, this would have been sudden and devastating. Even after this event, rising sea levels continued their slow advance. Eventually, the last pieces of Doggerland disappeared beneath the water. What had once been a vast inhabited landscape was gone. Britain, which had been connected to Europe for thousands of years, became an island. Today, Doggerland is completely submerged, but it has not been forgotten. Scientists have been able to reconstruct what it looked like using modern technology. By studying the shape of the seabed and using data from oil and gas surveys, researchers have mapped ancient rivers, hills, and coastlines hidden beneath the sea. This work has revealed just how large and complex this lost world once was. Artifacts continue to be discovered. Fishing boats have pulled up tools made of stone and bone, along with remains of animals that once lived there. In some cases, even fragments of human skulls have been found. These discoveries confirm that Doggerland was a place where people lived for generations. But lost land is only part of the story, because the Atlantic is not just deep, it is layered. For a long time, the ocean was understood in simple terms as a continuous body of water stretching from the surface down to a solid seabed. Modern observations, however, show that this view is incomplete. The Atlantic is structured in layers, formed by differences in temperature, salinity, and density. Warm water remains near the surface, while colder and denser water settles at greater depths. Between these zones, there are transition layers where conditions change rapidly, creating distinct boundaries within the ocean itself. Although these layers are invisible, they have measurable effects. They influence how water circulates, how heat is distributed across the planet, and how marine life adapts to different depths. In certain conditions, the differences between layers become strong enough to affect the way sound travels through water. When sonar signals pass through the ocean, they can reflect off these boundaries, producing readings that resemble a solid surface within the water column. This phenomenon, often referred to as a false bottom, does not indicate the presence of any physical structure, but rather a sharp transition between two water masses. Early interpretations of such signals led to confusion, as instruments appeared to detect depth or structure where none physically existed. Over time, as oceanographic research improved, these effects were better understood as part of the ocean's internal complexity. The Atlantic, in this sense, behaves less like an empty space and more like a layered system with its own internal organization. Even with current technology, this structure is not fully mapped. When discussing the depth of the Atlantic, references are usually made to specific known points, such as deep ocean trenches. However, these measurements represent only a fraction of the entire seafloor. Large areas, particularly in deeper regions, remain explored only through indirect methods, and detailed mapping is still ongoing. As a result, while the deepest known locations have been identified, the full extent and shape of the Atlantic's bottom are not yet completely defined. This leaves open the possibility that aspects of its structure, both within the water and along the seabed, remain to be understood. Importantly, the complexity of the Atlantic does not end with these water layers. Beneath the ocean floor itself, some additional systems and formations extend beyond the visible boundaries of the sea, suggesting that the structure of the Atlantic continues even further below. In one of the most striking recent discoveries related to the Atlantic Ocean, scientists have confirmed the existence of a vast body of fresh water buried beneath the ocean floor along the eastern coast of North America. The finding, announced following a major international research expedition, reveals that large volumes of freshened water are stored deep below the seabed, extending across parts of the continental shelf. At first glance, the idea appears unexpected. Beneath salt water, within layers of sand and sediment, researchers have identified water that is significantly less saline than the surrounding ocean. This underground system consists of aquifers, layers of sand and rock beneath the seafloor that store and slowly move fresh water. The discovery was made during IODP-NSF Expedition 501, a scientific drilling mission conducted off the coast of southern New England. Using specialized offshore drilling equipment, researchers extracted nearly 900 meters of core samples from beneath the ocean floor. These samples provided direct evidence of water stored within different sediment layers, allowing scientists to analyze its composition, depth, and distribution with a level of precision not previously possible. The results showed that a substantial zone of freshened water exists at depths reaching up to 200 meters below the seabed. This layer is spread across a complex structure of sandy aquifers and clay-rich barriers known as aquitards. These formations act together to trap and preserve water over long periods of time. Although often described in headlines as an underground sea, the system is better understood as a series of interconnected reservoirs rather than a single continuous body of water. Also, the water is not completely pure fresh water. It contains significantly lower salinity compared to seawater, indicating that it originated under different environmental conditions. Scientists believe this water formed over thousands to millions of years. During past ice ages, when sea levels were much lower, large portions of what is now the continental shelf were exposed land. Rainwater and meltwater from glaciers likely seeped into the ground, filling underground layers. As sea levels gradually rose, these water-bearing sediments became submerged, sealing the fresh water beneath layers of ocean deposits. Over time, some mixing with seawater occurred, but the overall structure remained intact. This created a preserved system that reflects ancient environmental conditions, effectively acting as a geological record of past climates and sea level changes. Despite the scale of the discovery, researchers emphasize that this is not a practical new water source for modern cities. Extracting water from beneath the ocean floor at such depths would be technically complex and economically challenging. Additionally, disturbing these systems could have unintended environmental consequences. Instead, the significance of the finding lies in what it reveals about the Earth's history and the behavior of water over long time scales. These offshore aquifers provide insight into how coastlines have evolved, how groundwater systems respond to rising sea levels, and how sediments interact with both marine and freshwater environments. The discovery also highlights the role of the continental shelf as an active and dynamic zone, rather than a passive boundary between land and ocean. Beneath the surface, chemical processes, fluid movement, and even microbial activity continue to shape these hidden systems. For scientists, this represents an important step forward in understanding the Atlantic Ocean, not just as a body of water, but as a layered and interconnected system extending below the seafloor itself. Beyond these layers, deeper beneath the surface, lies one of the most significant geological structures on Earth. Running through the center of the Atlantic Ocean is a vast mountain range known as the Mid-Atlantic Ridge. It stretches for nearly 16,000 kilometers, from the Arctic Ocean in the north to waters near Antarctica in the south. In total length, it surpasses any mountain chain found on land, making it the longest continuous mountain range on the planet. Unlike the Himalayas or the Andes, this mountain system is almost entirely hidden underwater. Its peaks, valleys and ridges remain out of sight, covered by thousands of meters of ocean. Only in a few locations, such as Iceland or the Azores, does this structure rise above the surface, offering a rare glimpse of what exists below. The Mid-Atlantic Ridge runs almost perfectly between continents. In the north, it separates the North American and Eurasian plates. Further south, it divides the South American and African plates. This position marks a boundary where the Earth's crust is slowly pulling apart. At this boundary, tectonic plates move away from each other at a steady rate of a few centimeters per year. While this movement is slow on a human timescale, it is constant. As the plates separate, molten material from beneath the Earth's crust rises to fill the gap. This material cools and solidifies, forming a new ocean floor. This process is known as seafloor spreading. It means that the Atlantic Ocean is not static. The seafloor itself is continuously being created along the ridge and pushed outward over time. The farther one moves away from the ridge, the older the ocean floor becomes. Near the center, the crust is relatively young. Toward the continental edges, it is significantly older. This discovery reshaped how scientists understand the Earth. It provided key evidence for the theory of plate tectonics, showing that continents are not fixed, but slowly drifting apart. The Atlantic, in this sense, is a space that is actively forming, not simply existing. Yet the Mid-Atlantic Ridge is more than a geological boundary. It is a landscape in its own right. Along its length, the ridge forms a rugged terrain of underwater mountains, deep valleys and fractures. At its center lies a rift valley, a long depression where the separation of plates is most visible. This valley can be tens of kilometers wide, with steep walls and uneven terrain shaped by volcanic activity and shifting rock. In many areas, the ridge is marked by frequent earthquakes and volcanic eruptions. These events are usually hidden beneath the ocean, but they play a constant role in shaping the seafloor. Over time, they build new structures and alter existing ones, creating a dynamic and ever-changing environment. Along this shifting terrain, scientists have identified one of the most remarkable features of the deep ocean. These are hydrothermal vents, openings in the Earth's crust, where seawater interacts directly with the planet's internal heat. Hydrothermal vents form along cracks and fractures in the ocean floor, particularly in regions like the mid-Atlantic ridge, where tectonic plates are actively separating. Seawater slowly seeps down through these openings, traveling deep into the crust. As it descends, it encounters extremely hot rock and molten material. The water is heated to temperatures that can reach between 300 and 400 degrees Celsius. Under normal surface conditions, water at these temperatures would boil instantly. However, in the deep ocean, the immense pressure prevents it from turning into steam. Instead, it becomes a superheated fluid, rich in dissolved minerals pulled from the surrounding rock. Eventually, this heated water rises back up and is expelled through the vent openings. As it comes into contact with the near-freezing seawater around it, the minerals rapidly solidify. Over time, this process builds tall, chimney-like structures, sometimes several meters high, known as black smokers or white smokers, depending on the minerals they release. At first glance, these environments appear completely hostile to life. There is no sunlight. Temperatures change drastically within a small space. Toxic chemicals fill the water. The pressure is immense, far beyond anything experienced at the surface. And yet, life exists here. Around hydrothermal vents, entire ecosystems have formed in conditions once thought impossible for living organisms. These ecosystems do not depend on sunlight, unlike nearly all life on Earth's surface. Instead, they rely on a different source of energy. At the base of this system are microscopic organisms that use chemical reactions to produce energy. This process is known as chemosynthesis. Rather than using light, these organisms convert chemicals such as hydrogen sulfide into usable energy. This allows them to survive and multiply in complete darkness. These bacteria form the foundation of a food chain unlike any other. Larger organisms depend on them directly or indirectly for survival. Among these are giant tube worms, some growing over 2 meters in length, with no mouths or digestive systems. Instead, they rely entirely on symbiotic bacteria living inside their bodies. Other creatures include unusual species of crabs, shrimp, and fish, many of which have adapted to the extreme conditions in unique ways. Some lack eyes entirely, while others have developed specialized sensors to detect heat or chemical signals. Their forms and behaviors often appear unfamiliar, shaped by an environment that follows different rules than those on land or near the surface. Because of this, hydrothermal vent ecosystems are often described as resembling environments found beyond Earth. They provide a model for how life might exist on other planets or moons, particularly in places where sunlight does not reach, such as beneath the icy surfaces of Europa or Enceladus. Despite decades of research, much about these ecosystems remains unknown. What has become clear, however, is that the deep ocean is not empty. The discovery of life around hydrothermal vents has led to a broader question about the history of life itself. If complex ecosystems can exist without sunlight, then the conditions required for life may be different from what was once assumed. For much of scientific history, it was believed that life on Earth depended entirely on energy from the sun. Photosynthesis was seen as the foundation of all biological systems. However, the existence of vent ecosystems demonstrates that life can be supported by chemical energy alone. This has led some scientists to consider the possibility that life on Earth may have begun in environments similar to these. Early in the planet's history, the surface of the Earth was very different from what it is today. Conditions were unstable, with frequent volcanic activity, high temperatures, and a lack of oxygen in the atmosphere. The oceans, however, provided a more stable environment, particularly in deeper regions where external conditions had less impact. Hydrothermal vents may have offered the necessary ingredients for the emergence of life. They provide heat, chemical energy, and a constant supply of minerals. The interaction between seawater and rock creates complex chemical gradients, which can drive reactions essential for the formation of organic molecules. Some theories suggest that the first simple life forms may have developed within these environments, using chemical energy as their primary source. Over time, these early organisms could have evolved, adapting to new conditions and eventually spreading to other parts of the ocean and later to the surface. This idea is supported by the observation that many of the organisms found near hydrothermal vents are among the most ancient branches of the tree of life. Their genetic structures suggest a long evolutionary history, possibly tracing back to some of the earliest forms of life on the planet. If this interpretation is correct, then the deep ocean is not just a place where life survives under extreme conditions. It may be the place where life began. This perspective changes how the Atlantic Ocean is understood. It is no longer just a body of water covering geological structures and lost landscapes. It becomes part of a deeper system that connects the surface world to the processes that shaped life itself. The Mid-Atlantic Ridge, with its vents and shifting crust, represents an environment where the Earth is still active in creating and transforming. Within it, conditions exist that mirror those of the distant past, offering insight into the earliest stages of biological development. At the same time, much of this environment remains unexplored. The scale of the ridge, combined with the depth and difficulty of access, means that only a small fraction has been directly studied. Each discovery adds detail to a picture that is still incomplete. What is clear is that the Atlantic holds more than visible landscapes and recorded history. It contains systems that operate beyond everyday observation, preserving processes that have shaped the planet over millions of years. As technology advances, More of this hidden world will come into focus. But for now, vast regions remain beyond direct observation, and many of the processes that define the Atlantic continue unseen. In that sense, the Atlantic remains exactly what its title suggests, a forbidden ocean that holds Earth's true history, slowly revealing its past through layers of water, rock, and life that have yet to be fully explored. If this journey sparked questions or theories of your own, share them in the comments. And if you believe more people should discover the Atlantic Ocean's secrets, like this video to help spread the word. Keep your minds open, and until we meet again,